So today we're going to be looking at a sphere of charge. It could be a point charge. It works for that too. But let's say we have a sphere. So first we're going to want to find the electric field at some point outside of the sphere. Then we're going to look at a point inside. So let's start with the outside. So we're going to be using Gauss's law to figure this out. So this is the shape chosen to do the calculations with. It's the best shape because at all points E will be constant on it, and so that's good. So the sphere has a charge of Q, a radius of big R, and the radius of our shape outside is small r. So let's just do the calculations for that now. So we have E dot dA equals Qn over epsilon naught. Now, since, as I said before, E and the area as well, they're both constant, we can just say that it's E times A, because if we look back here, at all points here, we get that vector from the shape here. We want to call it n hat. We get that as being in the same direction as E, so we don't have to worry about the cosine. So E times the surface area of a sphere equals Qn over epsilon naught. So if we solve for E here, we get that E equals 1 over 4 pi epsilon naught times Qn over r squared, which is good because that's the formula for a point charge. So now we're going to look at the inside. So, So we have this point inside here that we want to get, and the setup's similar. We use the same shape, so we still get that E is constant and that other vector is in the same direction as E. So this time little r is this distance here. Big R is the same and Q is the same. So if we go to the calculations, we have E dot dA, and we get the same thing. We get E times the surface area of a sphere here, but you see here we have to solve for Qn. So to do that, we can say that big Q over Qn is equal to the big volume over the small volume. So we get 4 over 3 pi r cubed divided by 4 over 3 pi r cubed. Of course that's big R and little r. So those cancel, and we just get that Qn is equal to big Q times little r cubed over big R cubed. So if we plug that in for Qn and solve for E, we get that E equals 1 over 4 pi little r squared epsilon naught times big Q little r cubed over big R cubed. And these little r's cancel, we simplify that, clean it up, and we get that E for the distance inside is 1 over 4 pi epsilon naught times big Q times little r over big R cubed. So now we can check our units for these two equations to make sure that they're the same, because they should be. So we have this constant here, constant term in both equations, and we have coulombs over meters squared, and we get coulombs, and we got meters over meters cubed, so that would be meters squared. So that checks out, and that's Gauss's law applied to a sphere of charge, a metal sphere of charge, or a point charge.